Hello, I'm Channa Bankapur. I'm going to discuss my solution to the lead code problem, consecutive characters. It's today's problem in the November lead coding challenge. Um, the solution to this problem is easy. So we have a string of characters and we need to find the maximum length of a non-empty substring that contains only one unique character. What does it mean is we want to find the longest streak of a single character, a streak, right? Which are consecutive characters. So let's see a few examples that will be clear. So in the first example, we have there are two E's which are consecutive. That is the longest streak of a single character. And in the second one, there are five E's here that's repeating. So that's the longest streak. There are actually there are five O's here, and then there are 11 A's here. So that's how we can figure out what is the longest streak. And finding such a thing is not that difficult a task, right? So you start with a new streak, that means a character which is fresh, and then find how many times it repeats. And once you figure out a next character or as a different character or end of the string, that's going to be end of the string. So end of the streak. So keep track of the best streak found so far. All right. So here is my code. Let me quickly explain how does it work. So in this case, so I have a streak which is identified by a range like this. So the start of the range is going to be like this start index, and the streak ends before this end mark. So that's why I use this this kind of parenthesis indicating it is the difference or the size of the range is going to be end minus start, right? So that is easier to catch. So I don't need end as a variable outside of the while loop. So I always have the start is pointing to zero in the beginning, index is zero, and until so at the beginning of the while loop, the precondition is start is pointing to a fresh streak or end of the string. So when it points to the end of the string, that means we are done, and then we have a result here. We're going to return. Otherwise, I'm going to start a new streak here. So I'm going to point n to next to that start, because the streak always has at least one character, right? So suppose if you have like A something like this, and then B. So initially I'm pointing to here start, and then end is pointing here because end is always one more than the end of the streak, right? But I see that whether this character can be included in the streak, right? So that's why end is pointing to next one, start plus one. As long as end is not end of the string, that is to make sure we are not actually going beyond the string. And if the end character is same as the start character, I keep incrementing end. So when I come out of the while loop, obviously end is either pointing to end of the string or a new character, right? It's the beginning of a new streak. So that's why end minus start is going to be the size of the current streak, which is at the beginning of start, right? I keep track of the best, so that's why it's the max of result and end minus start. And I'm going to point start to the this end pointer that indicates that because that is the beginning of the new streak, right? That's how I'm gonna go to the next while loop, right? When start is pointing to the end of the string, we have a result. All right. So this is how it works. Let me see, um, compiling and running it. So let me submit directly. So right, yeah, it accepts, and it should run pretty fast. The time complexity of this one is, suppose there are n characters in the string, and it's going to work in linear time. So if you see here, in every iteration, I'm incrementing the end here once in the inner loop, and then start again starts with the end there. That's why uh, start is going to be incremented by the number of times this inner while loop runs. So that's why the overall number of times we are going to run is big of n. So this is big of n time, and space wise we don't consume anything. So this is big of one space, extra space, right? So this is the best we can do. This is the lower bound for this problem, and that's why this is the most efficient solution. All right. So yeah, let me know if you have a different perspective or different way of solving this kind of problem, and like the video and subscribe to the channel. Happy coding.